Okay, so we had bolted connection. This time we'll be having welded connection. Welding is a process of joining two pieces of steel. Ang tawag dun sa wine-welding natin are the base metal. Together by heating them to the point that molten filler material mixes with the base metal to form one continuous piece. Minsan nga, kapag nagwe-welding tayo, di ba, two pieces, tapos pinagkakabit natin sila, after welding, minsan, mas magiging matibay pa yung pinaka-welded part kumpara dun sa pinaka-strength ng material itself. Webster's defines welding as to unite metallic parts by heating and allowing the metal to flow together. The process of welding is quite complex, and the strength of welds is highly dependent on metallurgy, welding procedure, and the skill of the welder. So, the picture on the right side, actually, I just got this from an article. There is a man daw answering an ad that read, hiring welders, $18 to $28 per hour yung salary daw. So this man went to the employer, and when he arrived, he was told by the employer that he has to undergo a welding test. Okay? So after ng welding test, yung nag-a-apply na tao ay nag-produce ng dalawang sets ng weld. Okay? Ito yung unang set niya na ibinigay. Ito yung pangalawang set niya ng binigay na welding. So nagtaka ngayon yung employer, bakit dalawa yung output na ibinigay mo sa akin? So sabi ng taong nag-a-apply, sir, the first one is my output if my rate would be $18 per hour. However, the second output, this would be my output if you will be giving me $28 per hour. So medyo piloso po yung tao, no? So ang point naman nito is malaking factor yung skill of the welder or yung welding procedure in terms of the output. Okay, so kapag ka ang type of welding is ganyan, no, diba, parang bara-bara lang. Okay? Parang dinut-dut lang yung welding rod dun sa metal, that's it. Pero yung number 2, tingnan mo, napaka-pulido. Napaka-swabe ng paglalagay ng weld. No? Consistent. Okay? So, which is, of course, that would be the better type of weld. We have different welding processes. Okay? The most common welding process that we are adopting here in the Philippines is the SMAW. Ito yun. Shielded Metal Arc Welding. Ito yung typical na merong welding rod. No? Tapos, dinidikit lang dun sa base metal, nasusunog siya. Yung welding rod, nako-form or nako-convert into a weld metal. So what we will be analyzing here later on is yung capacity ng weld metal, yung nasunog na electrode. Yung welding rod, yun yung electrode. So pag dinikit mo sa base metal, naluluto siya, nasusunog siya, tapos dumidikit na dun sa base metal. Yung dumikit dun sa base metal, ang tawag dun ay weld metal. So yung weld metal yung i-analyze natin in terms of its strength. Not to mention, we have different other possible processes of welding. We have the GMAW, the gas metal arc welding, as well as the flux cord arc welding, submerged arc welding, SAW. Okay, and itong mga different process na minention ko requires higher technology in the welding process. So basically, the weldability of the materials depends on the metallurgy. So I have a table here kung paano mo i-match yung grade ng steel with the type of weld that you're going to use. So let's stick to the first method, yung SMAW. If the base metal has a grade of less than 50 KSI, so as recommended, we have to use electrode 60 or electrode 70 welding rods for that. If the grade of your steel to be welded is from 50 to 60 KSI, medyo mataas yung grade na ng bakal, it is suggested that you have to use electrode 70. And kapag high yield strength from 60 to 70, medyo dapat yung electrode na gagamitin mo would be mas mataas din, electrode 80. Ano ba yung mga electrode 60, 70, and 80 nito? E stands for electrode. 60 is a numerical designation, and then X is a symbol. So, yan yung designation ng electrode. Ano yung sabihin yan? That is an electrode with an FU. FU is the tensile strength of the weld metal equal to that designation of 60 KSI. So, if you want to convert that to megapascal, times mo lang siya ng 6.9. Yun na yung magiging tensile, tensile strength ng electrode. Nung metal, nung weld metal. Pagka 70, 70 KSI. Pagka E80, 80 KSI. Kapag ka bumili ka ng welding rod sa maliliit lang na tindahan or hardware, kadalasan ang ibibigay nilang electrode sa inyo ay electrode 60. No? So pagka maliliit na mga hardware, electrode 60. Kadalasan binebenta yan per kilo. Kinikilo yan sa mga hardware. Pero pagka sa mga Home Depot, no, sa mga Wilcon or some malalaking tindahan na ng mga ganyan, doon you could find higher electrodes. Okay, so ito yung mga types of welds na pwede natin gamitin. So we have the groove weld. Pag sinabing groove weld, may groove kang ginagawa bago mo ilagay yung weld. Groove means uka, inuukaan mo. Inuukaan mo muna yung metal, tapos doon mo i-insert, doon mo finifill in yung weld mismo. Pero ang pinaka-common na ginagamit natin type of weld is the fillet weld, wherein hindi mo na usually nilalagay ito sa mga corners. No? So it could be placed here, it could be placed here, nasa corner siya, or it could be placed here. So take note of the parts of the fillet welds, this one. So these are the parts of the fillet weld. Take note of that na lang. We have slot and plug welds. So ginagawa to parang may hole, tapos finifill in mo yung hole ng weld. So para siyang nagiging lock. No? Para siyang shear key ang effect. Bevel welds naman ay ginagamit kapag nagko-connect ka ng mga tubulars or mga hollow, mga pipes sa certain pipe, sa certain split. Yan, ito yung bevel welds. Okay, so how do we analyze? Now, so let's move into welded connections. Okay, pagka welded connections naman, ang pinaka-limit state naman nito is shear. Okay, so we have to identify the design shear strength per unit length of fillet weld. So again, the design strength VRN should be greater than or equal to the R sub U. Again, the resistance factor for welded connection as well as with bolted connection is also the same as 0.75. And the design shear strength for welded connection is given by this. 0.75 is the resistance factor. So basically, the Rn for welded connection is given by this. 0.707 WFNW. Okay. Yung FNW, this is the shear strength. Define ba ito? Ayan. The weld ultimate shearing strength. FNW. Okay. So, paano na-derive yung formula na yan? Again, yung Rn is equal to 0.707 W times FNW. So, paano na-derive yan? Okay. So, shear strength of fillet weld. Okay. So let's take a look of a single lap joint. Okay, so let's say you have this single lap joint. Tapos applied with RU. That is the tensile load. Say RU. Okay, tapos instead of drilling holes, i-connect ko silang dalawa using welds. So lalagyan ko ng fillet weld dito. So yan yung welding na nilalagay sa corner. Tapos maglalagay din ako ng fillet weld dito sa kabilang corner. So this would be the length of the weld. Haba ng weld length, L. Okay? Now, if you will take a look of the cross-section, ano yung itsura ng cross-section ng fillet weld? So, i-zoom in ko tong cross-section na to. Okay? I-zoom in ko. Pagka zoom in ko yan, bali parang Ito yung plate. Lalakihan ko yung plate. So, ganyan kakapal yung top plate. Tapos, ganyan kakapal yung bottom plate. Kunwari. So, yung pinaka-cross section ng fillet weld, ng weld is ito. So, ito yung cross section ng fillet weld. So, yung length ng fillet weld is perpendicular na sa screen natin. Okay, so yan yung pinaka cross section, para siyang quarter of a circle. Pero hindi yan perfect arc ng circle eh. No, kasi parang imagine mo yung electrode, idinikit lang yan doon, tapos nasunog, tapos inangat mo yung electrode, na form yung ganyan. So this is not a perfect quarter of a circle. Okay. So let me identify the parts. So yung pinaka-corner na to, ang tawag dyan, ito yung root ng fillet weld. Root, corner. Okay? Tapos ito, ang tawag dito, yung pinaka-surface is the actual face. Actual surface or actual face of the fillet weld. Okay? So, tapos yung dimension na to, the distance from here hanggang dun sa root, ito yung legs kasi, legs ng weld. Ito rin, legs ng weld din yan. So, isipin, ito yung length of the legs of the weld, W. Length of the legs. So, W is the length ng legs, length of the legs of fillet weld. Sometimes this is also known as the size of the fillet weld. So pagka tinanong sa iyo, anong size ng fillet weld mo? Kunwari, 4 mm. Pagka 4 mm, isabihin nun, yan yung dimension ng W. Okay? Okay, so to make it simplified, instead of considering the actual face, ididiretso ko na lang to. So straight line. So ito na ngayon yung theoretical face. Theoretical face of the fillet weld. Now, so ibig sabihin, yung naging cross-section ko na ng fillet weld, naging triangle. Isosceles right triangle. And kapag hinila mo siya ng aryo rito, the fillet weld would be failing against shear. So pagka nag-fail yan against shear, the shear failure would be coming from the root and it will propagate towards the theoretical face. And syempre, yung pinaka-critical would be the shortest distance. And the shortest distance is always the perpendicular distance. And that shortest distance is known as the T, throat. Hindi yan thickness ha. T is for the throat of the fillet weld. Throat of fillet weld. Okay. So since this is an isosceles triangle, W equal yung length. So length ng legs, this is 45 degrees. Okay? 45 degrees. So if I solve for the Rn would be FNW times the area for shear. Okay? Yung FNW, ito yung shear eh. So that is 0.6 of the electrode use. Halimbawa, yung electrode use mo is E60, hindi 60 KSI yung ultimate tensile strength nun. Kuha mo yung 0.6 nun, yun na yung 10, yun na yung shear strength nun, yung FNW. Now, ano yung area for shear? Yung area ng shear is yung throat times yung length ng weld. Can you imagine? Imagine mo yung throat times times mo dun sa length perpendicular sa screen. So, yun yung rectangle na yun. Yun yung sheared plane or sheared area na nag-occur for fillet weld failure. Now, but most of the time, fillet welds are expressed in terms of its size W. So, how would I correlate throat T in terms of W? So, considering this triangle, ito, yung triangle na to, may 45 degrees. Diba? Sine 45 degrees is equal to sine is opposite T, throat, divided by hypotenuse, W. Nakita niyo yung triangle na yun? Ito. Diba right angle to? Ito yung throat, ito yung W, ito yung 45 degrees. Okay, so trigonometric function, sine 45 is equal to T over W. So therefore, I could say that the throat is just equal to sine 45 degrees times W. And that is actually, sine 45 is 0.707 W. Kaya ito ay naging 0.707 W times L. So, substituting everything back dun sa equation, so therefore, our Rn becomes, ano AV? AV is 0.707 W times L. L is unit length. Diba sabi kanina, we are analyzing per unit length, 1 millimeter length of weld times FNW. So, dyan nang galing yung RN equation natin. Okay? Then you just have to check lang, no? So again, these are the values of the electrodes. Depende sa electrode na gagamitin. I just converted it to megapascals. Tapos kuhain mo lang yung 0.6 niyan. Pag nakuha mo yung 0.6, yun na yung FNW na gagamitin mo rito sa formula ng RN. Okay, so you have just to check the base metal shear. Kasi minsan, mas sumihina yung pinaka-wine-welding mo na bakal kumpara dun sa pinaka-weld metal. So you just have to check the shear yielding strength by solving this design strength. At the same time, yung shear rupture strength ng bakal by solving its design strength here. Okay, so you just have to compare with itong VRN ng weld metal with the VRN ng base shear, base metal shear. No? Kasi baka mamaya mas gumina yung strength ng base metal. Tapos, kapag yung weld mo is combination ng longitudinal and transverse, ang sabihin niya, ito yung pinaka-plate mo, tapos kunwari may welding ka rito, kunwari dito yung force, yung RU, yung welding dito, ang tawag dito longitudinal. Tapos yung welding dito rin, longitudinal. Tapos, paano kung may welding din dito? Transverse. Kapag yung welding mo is combination siya ng transverse tsaka longitudinal, you have to check it with this provision. Use the larger nominal strength from A or B. Okay, yung RNWL is for the longitudinal, tapos yung RNWT is for the transverse. Okay, so you just have to solve for these values of Rn, and whichever is larger, yun na yung magiging Rn nung combination of longitudinal and transverse welds. So, meron tayong limit in terms of size. Ito yung W, minimum. And the size of weld depends on the thickness of the thinner part, yung mas manipis. Kung halimbawa, may 10 mm, tapos may 8 mm ka rito, dalawang plate, magkaiba ang thicknesses. Hanapin mo kung sino yung mas maliit, 8 mm. Hanapin mo yung 8 mm kung nasaan siya rito, so nandito siya papasok. So, kapag ganun yung kinoconnect mong metal, ang minimum size daw should be 5. Hindi ka pwedeng gumamit ng size na mas mababa sa 5 mm. Okay? So, kung may minimum size tayo, meron din tayong maximum size. Again, the maximum size of the fillet weld, W max naman ang tawag dyan, ay depende ulit yan sa thickness ng mas manipis na ikinakabit mong bakal. Kapag manipis siya in such a way that the thickness of the thinner part is 6 mm or less, the maximum size would be the thickness of the material. Kapag yung thickness ng mas manipis mong plate is 6 mm or more or mas makapal, the W max would be the thickness of the material, babawasan mo ng 2 mm. Yung 2 mm na yan yung to make sure na pagka nag-welding ka, meron siyang clearance. Ito yung pinaka-welding na yung nilalagay mo. Dapat pagka nag-welding ka, wag mong pupunuin, wag hanggang sa ibabaw. Dapat may clearance ka rito na at least 2 mm. Okay, so yan yung ibig sabihin ng code na yan. Also, in terms of the length of the weld, it should be greater than 4 times the size of the weld. Halimbawa, ang size ng weld mo, kunwari, 10 mm, so dapat ang length mo should be at least 40 mm. Hindi pwedeng bumaba sa 40 mm. 4 times the size of weld. Kung meron tayong minimum length, meron din tayong maximum length by just checking it with this provision and with this provision as well. Tapos meron tayong tinatawag na end return. This is to make sure, ito yung end return, yung ibinabali natin yung weld dun sa dulo. Halimbawa, meron tayong plate na kung saan ang weld talaga lang natin dyan is longitudinal. Kunwari dito. Ito yung load, no? Longitudinal weld lang. Okay, kaya lang kapag nag-welding tayo hanggang dulo, minsan kasi pag yung iba nag-welding hanggang dulo, hindi umaabot hanggang dulo. So to make sure that the length would be fully effective up to the dulo, kailangan i-return mo siya ganyan. Ibinabali mo na rin yung pinaka-weld mo dun sa dulo dito. Okay, that is to make sure that the weld would be fully effective up to the last point. Okay, so yung tawag doon ay end return. Okay, so ayun. So that would be the provisions that we have to follow when it comes to welded connections.